Namaskar my dear friends. Let's talk about LTSpice simulation. We will introduce you what is LTSpice and how quickly we can simulate our circuit, how quickly we can draw the circuits, what are the different shortcuts, and what is the best way to simulate the circuit in our LTSpice simulation tool. So just open your LTSpice simulation, and what you will see is you will see this particular window. So this is the new window that has been introduced by analog devices. So very first thing that we have to always do is we have to go file and open a new schematic. So to open new schematic, either you can go file new schematic, that is one method. Another method is this is the plus button. So if you press this, you will get another circuit. So you can see untitled has come for new circuit. Okay, one more, so untitled does like draft schematic 3. So it keeps giving you, like untitled it has given by file new schematic. Okay, so like that it keeps give you. Anyway, if you want to cut them all, so one by one you can cut them, not by here, by here. So if you keep removing them, it will all get removed. Understood? So you just open a new schematic like this. Coming back to the other parts, like if you want to have like symbols, if you want to have new symbols, all those things, the main thing is if you want to open existing file, then you can go ahead, open Control O, and if there is some already function that is available or some file that is available, then you can open them. I am not going to do that right now. Other thing is it has lot of toolbar buttons that I'll tell you one by one. Okay, so before that, let me just draw you a very simple circuit so that I can make you understand how it works. Okay, so I'll take a voltage source, I'll take a resistor, and I'll take one diode, and then I'll take one ground. Okay, so this is a very simple circuit that I'll just draw here so that you can understand how it will work out. Okay, and it will be easy for me to take this as a reference and tell you different powerful functionalities that is there with this LTSpice. Okay, good. So coming back to the point where we are going to draw this particular circuit quickly. So what we will do is, if you want to put down a resistor or a capacitor or all those things, there are toolbars that is given here. This is the ground. If you press this, you will get a ground. Okay, so keep pressing other, so you will end up like getting so many grounds that you want to put. So whenever you are there in this phase, you have to keep left click, it will keep on giving one ground on the circuit. Okay, if you right click, it will go away, or you press escape, it will go away. So this is how you come out from this particular thing. If you want to delete them, then what you can do is you can press delete button, then you will see a scissor symbol. Okay, so press delete button, then you will see a scissor symbol, or otherwise just escape it. One more thing is, this is the cut button. Okay, so you click this, you will get a scissor button, and this is how, if you want, you can cut one, or otherwise you can select all of them and cut. So this is how cut and place the symbols, right? Coming back to, if you want to place a V like voltage source, you can click on that and put a voltage source, put another voltage source, put another voltage source, like that. If you want to come out from this, escape it. Okay, if you want to put resistor you can put. If you want to put capacitor you can put. If you want to put diode you can put. If you want to put another components, so this is the component window where all the component list are there, and you can type a name and it will appear, or otherwise you can go and select one of them. So this is NPN transistor. If you just want to place, just place one. It will never come out unless you click right click or otherwise escape. Okay, so it will keep giving you. Now you may wonder, like, how to rotate this particular symbol before I place on this. So to rotate this particular symbol, either you can place Control R. Okay, so press Control R, then it will keep rotating 90 degree. Okay, so keep pressing Control R, it will keep rotating. Let us say you want to mirror them, like it is left side, I want to take it right side. So Control E, Control R for rotation, and Control E, Control plus E will be mirror. Okay, so Control plus E will be mirror. Okay, so it is kind of mirror. Understood? So this is how you can place wherever way, whichever direction you want it. Okay, so let me just delete all of them. So what I'll do, delete button and then select all of them. All of them are deleted. If you want to make the circuit bigger or smaller, you can like pull your mouse wheel, rotate your mouse wheel, it will become bigger or smaller. So like this it is there. Now the other thing that comes up is, let us say I want to move this particular resistor little bit, like this side or that side. So what you can do is there move function or something like that. So this is copy function, duplicate. This is copy function. So suppose I want to copy this resistor. So I'll just put this one. So this has been copied, and one more copy. This one again, if you want, again one more copy. Like that, keep on copying one by one. It is there, and then press escape. It will come out. So all same values, if you wanted to copy, it has copied one. So let us say I have to put some value. Then what we will do is, let us say I want to define a value for R1. So just right click it on this particular component, and you will get resistance value to be put. So you can put 10k. Either you put capital K or a small k, both will be kilo ohm. Okay. So now if you copy again, so what will happen? Just press copy this symbol and then press this one. So this will give you 10k. This will give you 10k. Like that it will keep giving you 10k. Now just press delete and then delete all of them. Okay. Now let us say I want to move this particular resistor somewhere else. So what I'll do is, this is move, or you can press M. Okay. So press M, this will be move. This is actually control C, that is copy. Okay. So this is move M. So this will be moved. So this is how you are going to move them. Understood? If you want to move somewhere else, you can move them like that. So let's move back again. What you have to do? Move back. Understood? If you want to stretch them, let us say I don't want to move them, I want to stretch them, like it should be like stretched up, but connection should not be removed. So you have to press stretch, this one, or otherwise S for stress. Okay, stretch. So just press it and it will be moving like this. Understood? So like that you can keep moving. If you want to stretch this, you can stretch that like this, and this is how it is stretched up. If you want to stretch it like this, you can stretch it and make it little bit more better, like that. Understood? So this helps you to reorder your circuit. Coming back to undo button, so you can keep it undo or control Z. So this is very similar. Now why I love this new version of LTSpice is because it is very similar to our MS Office functionalities or MS Office shortcuts. Okay, so if you control Z, you can keep coming back to the original value that you want it. Okay, and redo, undo, all those things are there. Now whenever you run this particular circuit, there are possibility. Let us say what I will do is, this is the place .ac, which is the configure analysis. Okay, or this is the place where it is run analysis. So if you have not run this particular circuit, you can place run and it will give you still the functionality to configure the like circuit simulation. So what I'll do is, first I'll go to configure analysis, and this is telling lot of other functionalities, let's say transient analysis or AC analysis or DC sweep. So we will see one by one each of them later on, but right now I'll just do transient analysis. So in transient analysis, what it says is, what is the stop time that you want to stop for this particular simulation. So for that purpose, let's say you want to give a time of, let's say 100 millisecond you want to give. So 100 millisecond is 100 m. Okay, and then what time you want to start saving your data. So you want to start saving your data from 10 millisecond, 20 millisecond, you can give that time. Otherwise I can give no value, then it will take 0, or otherwise you can start giving 0 also. So it will save start saving data from 0 onwards. You can place this particular transient analysis like function anywhere in the circuit. Okay, now if you run this particular simulation, then what will happen is, it will open a window and it is giving you a lot of error. As you can see, we have lot of error that it doesn't know what is the value of R or value of V. Okay, so you just remove this and we'll try to put this value of V. Now let us say, first of all, I'll just not give the value of V first. First we'll try to understand how this functionality is working. So as you can see, this is my waveform window and this is my schematic window. So waveform window is this side and schematic window is that side. It may be possibility that you are getting waveform window upside or downside. So this is the window settings that you can set. Okay, so if you set this tile up and down, it will come up and down. Okay, If you set this side by side, it will come side by side. So like this you can keep doing. Okay, so whichever way you like, you can do that. So sometimes it looks good this view, and sometimes it looks good this view. Understood? So if you are not able to see this particular circuit, what you have to press it, let us say some big circuit is there or very small it has become, and you want to fit this particular window properly, so just press space bar, then you will be able to see proper window. Okay, so or otherwise if you are in this phase, press space bar, it will make it proper fitting to the window. Okay, so with whatever big circuit or small circuit is there, it will fit completely inside the window. Understood? Now let's put the values of all these parameters. So what we will do is, if we want to understand what is the value of V, just right click it and give a value to this particular voltage. So if you want to give just 5 volt or something, you have to just write 5 and it will take 5 volt. If you want to write V also, no problem, but it will take 5 only. Now if you want to run it, you run it again. So it has run, and let's say you want to see what is the voltage value of my this particular voltage source. So in that case, you just probe on this particular net and it will give you the value which is shown here, 5 volt. Understood? If you want to see at this place, you will see that another value, but the problem will be, you can see here the name of this particular trace, particular waveform is VN001. It means it has by default name this particular net as N001. If you see this particular net, let us say I am going to press voltage probe on this one, then again it will become VN002, and you will see the value of that particular net is around 4.4 volt or 4.35 volt. Understood? So this is how 4.35 volt, and this is 5 volt. It means it is taking around 0.65 volt drop. So the diode drop is 0.65 volt. That's the reason we are getting this thing. But to understand, make it much more understandable, what we will do is, we will always keep some net names on these particular wires. Okay, so for net naming, what we do is, there is something called as like net, net, or you can press N also. So either you press this and it will net will come, or otherwise you press N, so N for net, and you give a net name. So any suitable net you want, you can give. So let us say I want to give V in. So for that, then press OK. Then this particular net is appearing. You can see there is a node appearing down. You have to make sure that that node gets connected to the particular wire or particular net that you want to put in. Don't put anywhere else, otherwise it has no meaning. Okay, so place on this particular net, then only it will get connected to that particular net. So I have named that input net as V in. Now you want to name other nets also, so either you can escape and again go to net and name the other nets, otherwise you can keep the same name and then change the name. Okay, so I am just going to put the same name and just escape and right click on this net and change the name as V out. Okay, so this is how my input is V in, my output is V out. Now I'll just rerun it. So if I rerun it, then what is going to happen is, the window is now vacant, like it is very clean. Now if I probe here, then I will see V in has appeared, and this I will see V out has appeared. Understood? Now coming back to the fact that, see, I am not able to see proper scale in the left side. So if you hover here, then you will see there is a arrow mark and there is scale appearing. Okay, so what will happen is, if you want to scale it properly or maybe put a tick mark properly, then right click it and then you will see there is top, tick and bottom. Okay, so let us say I want to see from 0 to 5 volt or 0 to 6 volt. So I can put bottom as 0 and top, let us say I will give 6 volt. Okay, so it will give me 0 to 6 volt. In a step of, let us say I want to have 0.5 volt onwards. So 0.55 volt, it will give me 0 to 6 volt. Understood? So let us say you can see 0 volt to 6 volt and in a step of 0.55 volt, right? So this is the understanding of, like proper scaling. So you can see my output voltage is just below 4.5 and my input voltage is 5 volt. Understood? Now if you want to measure what is the current across the resistor, so you have seen the voltage at this particular node. If you want to see at voltage at ground, then what will happen? This will be giving you ground voltage. Okay, now let us say I want to see what is the current across this resistor. So current across any component, if you want to see, you have to go and hover over the component. So you will see there is a change in the probe. If you see, this probe is looking like a voltage probe, red color, and this probe is looking like current probe going into the current mode. So now if you click, there will be a current appearing in the waveform window, right? So if you press this, you are seeing right side there is current and left side there is voltage. Okay, so the red color is showing you IR1, that is current through R1. So R1 is the name of this particular component, and I is the current indicator, V is the voltage indicator, P is the power indicator, like that. Okay, so I am going to see I as a current across the R1, which is shown here around 436 to 436 6 point, so around 436 microampere. So let's change the value to let's say 1 kilo ohm, it will be in milliamps, let's say. Now if you rerun it, what is going to happen is it is saying 4.3 milliamperes. Okay, let us say if you want to see exact value of this particular current, then what you have to do is go on this particular name. Okay, go on this particular name and left click it, and then you will get one cursor window. Okay, so once you go, or otherwise you can go here, otherwise you can go here. So whichever name you go, you will get cursor according to that, corresponding to that particular variable. Okay, so I want to see cursor for this particular current. It means I will go here and I will press click. So you will see there is a cursor that has appeared here, and you will see there is horizontal value, there is vertical value. So vertical value is this time parameter, it will show. You can see hover over this cursor, and you will see 1 means cursor 1. So you can see cursor 1 is there, we have cursor 2, cursor 3, all these things are keep on coming. Okay, now cursor 1 you can keep on rotating, you will see horizontal is changing. Left side you can see this, just concentrate here, I am rotating here. Okay, so I am moving left and right, and my horizontal is moving millisecond. Vertical is not moving because vertical is constant line, so that's the reason it is not moving. If you want, you can move up and down, but it is not moving because it has intact to this particular waveform. Okay, so you can see it is 4.3 milliamperes. Understood? Now you can come out. Now let us say you have this particular schematic window and you want to change the thickness of this node or thickness of the circuit or something like that. Then what you can do, or you want to change the thickness of this particular waveforms, whether you want to make it thinner or thicker, or maybe you want to change the colors or all those things. So how you can do all those things permanently, or like a temporary basis. Okay, so let us say you want to change the color of this particular V out temporary basis. So what you can do is go here and right click, then you will get a window, and in this right click window you can see default color is this, and you can change the color according to your choice. So let's say we want to make it purple, so that color will become purple. Understood? Let us say I want V output, it is showing me around 4.5 volt, right? 4.35 volt, right? So what we'll do is, let us say I want to have minus of this V out. So minus of this V out will be minus 4.5, right? So it means you can manipulate this particular output according to your algebraic expression. Okay, so I'm just showing you the methods how you can do the changes. So let us say you want to multiply it by 2 times. So whatever V output is coming, I should see twice of that. That also 2 times, that one you can do. So first of all, I'll tell you negative of that if you want to see. So it will become negative of that. So you can see it is minus 4.32. If you want, you can have a cursor on this, and you can see minus 4.30 is coming. Okay, now let us say I want to see negative of 2 times of that. So go here and right click and put down negative of 2 times of this one. So it will say 4 to the 8.6, right? So it will say 8.6. See, it is showing 8.6. So you can go here and left click, you will get one cursor, and it is showing 2 times of V out negative of that, that is minus 8.6. Understood? So this is how you can make changes of that. It looks much better if you change this particular voltage source to some other type. Okay, so how do we change this particular voltage source to some other type? Go here, right click it, this is the voltage source that is there. Okay, what we'll do is we'll go to advanced, in this advanced we have other functions like pulse source or sine wave or all these things. So let me just give you an introduction about pulse wave. So pulse wave is asking about what is the initial voltage that you want it. So let us say I want initial voltage to be 0. On voltage, let us say I want it 5 volt. Then delay, let's say I want 0, like I don't want any delay. Rise time you want, you can give very small, like let's say 1 microsecond or 1 nanosecond. If you want, you can give fall time and rise time, both things I am giving 1 nanosecond and 1 microsecond, 1 microsecond. Then let's say on time I want to give 10 millisecond and time period I want to give 20 milliseconds, so that on time and off time both are same. So you are going to define a pulse wave of or a square wave with 10 millisecond on time, 10 millisecond off time. So this will be defined like this. If you want to show this, you can show it. Otherwise, right click it and you can what you can do is you can right click here and let's say any of these particular parameters, let's say D you don't want to show or 1K you don't want to show, or you want to show some other direction, all these things you can change it by going into right click. So let us say I want to change this particular value, so right click on D and what you can see is it is showing justification top. So you can put it left, it will go to left. Understood? If you want to show it right, then it will go to right. It will go to bottom, it will go to bottom. All this thing, it is not changing because nothing is happening at this particular place. Okay, this will have better understanding. So let us say I want to make it vertical text. Okay, so it will become vertical. So this is how you can make changes. Understood? Or you want to make it right side, so it will go to right side. Got it? And if you want to hide it, so let us say I want to hide it. If there is hide option, not visible is there, yes, so not visible, it will not be visible. Understood? So just Control Z, it will be visible again. Now our main purpose was to see this particular pulse wave and see what is happening. So let's run this again and you will see that V input is, let us say we have three waveform like V input minus 2 times V output and IR1, right? So what I'll do is I just want V input again. So what I'll do is either I can go here and press delete button, then you will see go to the waveform window, click here, you are there in waveform window, press delete, then you will see there is a scissor button appearing, and go and delete that. So that is deleted, delete that, that is deleted. Like that you can do. Otherwise I have not pressed that delete button. Now otherwise what you can do is you can double click on this V in and rest all other waveforms will go away. Okay, so double click on this, only V in is appearing. Understood? And what is the V out? So V out will be just dropped by diode voltage, which is 0.7 volt or 0.65 volt. Understood? Coming back to the current through the diode you want, you can have diode current which is ID1. So ID1 is in red color, you can see, and that is just more than 4.4 milliampere or less than 4.4 milliamps. If you want to have IR1, so IR1 will be appearing, which will be equal to diode current because they are in series. If you want to measure power across this IR1, then what you can do is go over this particular R1. This is appearing into current mode. Now press Alt, then you will see some other symbol, that is power symbol. Okay, so some other Alt R, the Alt if you press, then you will change it to power symbol. Now if you click, it will calculate power. So you can see it is telling you V output multiplied by IR1. So voltage across this output node multiplied by IR1 is the power across this R1. Understood? So this is how power is coming. And power, you can see this is milliwatts that is showing you. So this power that is there, just more than 18 milliwatt, that is coming up. If you want to see the cursor, you can press here, so cursor will appear. Horizontal value of this cursor is showing you 18.5 milliwatt. So 18.5 milliwatt is the power across this particular resistor R1. Now let me just make it bigger and quickly tell you how to put quickly other parts. Like let's say you want to put it voltage source. So voltage source is V. V if you press, you will get a voltage source. G if you press, you will get ground. And G for ground, V for voltage source, and then D for diode. Okay, D for diode. Then if you press R, R for resistor. If you press R, R for resistor. If you press C, C for capacitor. So if you want to press immediately C, then C for capacitor. Then if you want to place inductor, then inductor will be L for inductor. Okay. If you want to place some other component, let us say you want to have some other component, so either you can go into that component window here, this component, or otherwise you can press P for components, and then you can search one component. Let's say I want to have PNP, so I'll just write down PNP and I can place one PNP. Okay. Again come to the component window by pressing P, and I can put NMOS. Okay, so NMOS is MOSFET. Okay, if I want to put PMOS, then I'll just put PMOS. Okay, so that is P channel MOSFET. Understood? If you want to put a current source, then what I'll do is I'll go to the component window, which is by pressing P, and then write down current, then it is coming as current window. Okay, if you want to rotate this current symbol and then put it down, then what you can do, press Ctrl R, then it is rotating. Understood? And this is how you can place this. Similar to all other like components, you have to right click on this and you will get an option to put the value of this particular source or particular component. So this will become 10 volt. If you want to press here, right click on this current source and then place let's say 10 milliampere, then current source will be becoming 10 milliampere source. If you want to change this particular value to some other methods, let's say go to advanced, then you can go ahead with pulse or go ahead with sine. So pulse I had showed you for voltage, same way it will be for current. If you want to have sine wave for this particular current, what you can do, let us say DC offset I don't want anything, so I will put 0. Amplitude, let us say I want 10 milliampere, and frequency, let us say I want 1 kilohertz. Let's say delay I'll just put 0, and I don't want any phase difference or something, so I'll just keep it as it is. You want a particular number of cycle, you can put it for, let's say 10 cycle or 20 cycle, otherwise you can keep it as it is, there is no problem. So press OK, then this particular current source has been defined as a sine wave. Now if you want to move this particular value so that it will be visible, so press M and then select, so that is move, M for move. Understood? Now you want to just run this particular source, what it is, then what you can do is put a ground source here and put a net here. Okay, net here, and then connect this also, W for net, W for this particular like wire. Okay, W for wire, this net is actually nothing but wire. Net is for net naming. So if you want to have net name, let's say I out I want to put, so this will be my I out on this particular net. Okay, now let us quickly run this. So what will happen, it is telling model R is not defined. Okay, so many things are not defined, you have lot of component like C, R, D, L, all these things are there, so none of them are defined. That's the only reason you are getting all these errors. So if you keep clicking OK, you will see a lot of errors that has been there. So it is, all these are warnings and some of them are errors. Okay, so warning may not matter, but errors will matter. So unless you remove them, this particular circuit will not run. Okay, so for our benefit, quickly what we will do is we'll quickly delete all these items which are not necessary. Just select them all and delete all. Okay, so now it is very easy for us to run this particular circuit. Okay, if you want to move this particular circuit closer to this source, then what I'll do, I'll press M and then select all and then move closer here. So this will be now, and then press space bar, press space bar, then you will get this proper fitting into the schematic window. Now what I'll do is I just want to see this particular current source, and you can see we have 10 milliampere and 1 kilohertz signal. So I should see a sine wave of 10 milliampere peak to peak value, and 10 milliampere will be peak value and peak to peak should be 20 milliampere value, right? So what I can do is I'll just run it. So once you run it, you are going to see a voltage probe here. So I don't want to see voltage probe, I want to see current. So I'll just press this, you will see lot of nonsense value is coming here. I'll just show you how to make it better. So I'll double click it, only this one will be shown. Okay, So you will see it is very cozy value. You are not able to see it properly, okay, because you have run it for 100 millisecond. So 1 kilohertz was there, it means 1 millisecond will be the one time period. So I just want to see 5 pulses. So for that, what I can do is I can go to this configure analysis, run it for, let's say, 5 millisecond. So 5 millisecond. So I will see only 5 millisecond window, so that I will be able to see proper output. So let's say I'll run it for 5 milliseconds, so you can see 5 millisecond window, right? And this is I of I1, which is showing you 10 milliampere and minus 10 milliampere. Understood? Now let us say if you want to measure the cursor, so you can see their cursor is appearing, and this one, now you can move it. This horizontal is also moving, vertical is also moving, because it is like following the particular waveform. Understood? So this is how you are able to see. Now if you want to change the color, same way, right click it, you have the color option, and you can change this particular color option to, let's say, red, then it will become red. Understood? Now let us say quickly what we'll do is we'll go to this tools, and this tools is having a setting window. So go to this setting window, and this setting window is going to give you all the examples of like schematic. If you see, we have pen thickness 3. Let's say I just want to make it 1, then this is becoming thinner. If you want to make it 5, then this has become thicker. So this is how you can change based on your requirement that you need. So if you want to have thicker or thinner, whichever kind of things you want in your schematic window, you can keep, go to schematic. How to go here? Let me cancel this. How to go there? Tools, settings, and in setting window go to this schematic, and then change the pen thickness to your required value that you want. Okay, so keep it 1 only, because 1 is very best one, which is very thin, that is better. Coming back to waveform, so waveform, let us say this is the waveform window that is being shown, and the data trace thickness is 3. So this will be generally in 1, so it will be seen very thin. Okay, so let's say 1, so this is becoming now thinner, which is not seen, right? So if you want to see it very properly, that's the reason what I had done is I had kept it little thicker. So let us say my waveform, tools, waveform, then go to make it 3, so it will become like bigger. Now if you have like waveform, other colors and all is there, so you can go to colors also. There is one more place, I'll just show it to you. So go to this color preferences and you have waveform colors. So there are 12 colors that is there. So whichever color you want to change, you can go and change them. So let's say color 2, I don't want to have this kind, I want to have little other kind. So let's say I want to have green little lesser, so it will become like this. Okay, or like this, it will become like this. So let's say this one is this one is looking better. So let's say I want to have voltage at this particular node, so second color should be looking at that one. Let's say this one. So see, second color is looking, that new changes that I just now made, that one is looking like that. Understood? So hope now you have a better understanding of how to start the circuit, and how to have different shortcuts to do the circuit analysis and all those things. At the same time, I'll just quickly show you how to save the circuit. So this is the save button, you can just save it. Okay, so it will be saved in this name, data draft8.asc, or you can go to file and put it save, then it will save it in the same name. Now if you want to save with other name, then what you can do, go and save as and put your own name. Let us say first circuit, first circuit. So if you name it first circuit, then it will go and save it as first circuit. So now first circuit is saved. Understood? And the raw value is coming as data trace value. So this is showing you first circuit data value. So this is how you can save it. Understood? All these toolbars, if it is not visible to your simulation window by some means or by any other reason, what you can do is you can go to edit, and you can see all these are already there, like text. Text I didn't tell you. What you will do is, let's say you want to write some comments or something for your benefit purpose, so you can go to this T. So this T is text, and you can write it down. This is my first circuit. Okay, so this is my first circuit. Understood? Now there are other things, let's say dot trans or something is coming, right click it, you will see that you have an option of changing this. You want, you can directly change it to let's say 10, then it will run for 10 millisecond. Understood? Got it? Or if you want to change directly from this configure analysis, you can change it here, or you can go to configure analysis and then also change it. Okay, there is something called as spice directive. So okay, that is called as dot t operation, which is called a spice directive. So spice directive is black color, so whatever you write in black, that will be shown here, and that will be a command for this particular circuit. So we will have lot of operation through the spice directive, like measure operation, or like some include new variables or something like that, or dot parametric operation, or step variables. All those things we'll try to understand one by one, but right now I am not introducing that things. So hope you have now a better understanding, a basic idea about how to quickly open the circuit, and how to save the circuit, what is the different methods of drawing a circuit. Okay, these are the like wires or ground or voltage source and all those things. So if you have any other application requirement, or any like doubts, then please put down your comments in the comment box, or queries in the comment box, and we shall be able to give you proper answers regarding this LTSpice, which is very fast and free, and like unlimited capabilities for any kind of your circuit simulations. So enjoy your days. Thank you.